I'm showing some slides, and then I will demo up some use cases. GDB and lldb debugging of my custom Raspberry Pi for Linux kernel. The motivation for doing such things is to understand how the Linux kernel works at the inner parts. And especially I had to debug a custom Linux kernel module from the beginning. So this is the motivation why I'm trying to debug on the hardware with a JTAG supported device. It's nothing new, but just showing how to do that for the Raspberry Pi 4. This is my setup. I have a Raspberry Pi 4, and I use a J-Link as a JTAG debugger. We go over to OpenOCD and connect with GDB versus lldb to the OpenOCD GDB server. The software I'm using is all free software. It's OpenOCD, it's GDB and lldb for the host platform. For the target, I have a custom U-boot as a bootloader for the Raspberry Pi and then 64-bit patched upstream Linux kernel. I use the root file system over NFS and bring in the kernel image over TFTP. I'm using a special version of the OpenOCD because I want to use also some extensions in order to have better views inside the state of my program. I want to use the Python extensions within GDB, and therefore I use this special version here. J-Link as an interface and a special target description for the J-Link debugger, which I'm showing here. If it's useful for the community, I can also share my files here. It's not so easy to get all the things working in practice, and so I did a lot of investigation in the internet, finally come up with this approach. Now I'm coming to the setup for GDB. How did I do that? Historically, I used an agent proxy to split the UART stream into a serial and a debugger stream. I then power on my Raspberry Pi and boot to the U-boot shell. In another terminal, I start OpenOCD and connect to my J-Link. And in the third one, I start GDB, the cross GDB, and connect to the GDB server from OpenOCD. And then I can start my Linux kernel, which I already provided some hardware breakpoints in order to see that I can debug from the beginning of the Linux kernel. And hopefully, if everything works, a breakpoint at start kernel will trigger. For lldb, I had to build lldb from source. That's my recipe, how I did that. And especially, I highlighted it here in red. I have to provide the lldb target in order to have the debugger. And this, I use also an extension called Voltron, where you can see a lot of details about the stack, about the memory, about registers and so on, about the source code. But I had to patch some things in the actual Voltron package. It's also, I can also deliver, if it's useful, the patches I did for that in order to get it working for RH64.
That would be useful, yes.
Yeah, I will share it. And lldb setup is more or less the same like the GDB setup. I'm only using something in order to share a shell with a lot of windows, I use something which is called tmaxinator and use that patched Voltron to get the information. Yeah, that's it. And I'd like to show something in action. Here you see my my UART output in this window. I have used a agent proxy, but it's not useful in this special use case, but I know I use it for other use cases. I will start my Raspberry Pi now, and hopefully it will boot into the U-boot shell. Okay, I break it here in order to start the OpenOCD with my custom config script here. You see it's waiting, just a moment, I try to, it's waiting here for the connection of GDB. And now I start my GDB. I have a custom GDB init script, which I can also share, which makes some preparation in order to use the Jeff extension for GDB. He reads in the symbols from VM Linux, and yeah, now I start the target here. You see here it's waiting for, it's running, the GDB server is running with live packets, and now I boot my kernel. I have prepared some hardware breakpoints. As you see here, now it triggers the first breakpoint. And you can see with these Jeff extensions, he's directly giving me the information where in the source I am. You have here a disassembly view. You have here some register views. I can continue. Another breakpoint will trigger. You see here now I'm at start kernel, the entry of the Linux kernel. And if I'm now running again, it will totally boot up here, as you can see in the UART output. In a few seconds, Linux 5.15 will boot.
And there, and this is booting Android on top of that. Which version of Android is this?
Oh, it's not booting Android any. It's a real.
Oh, okay.
It's only an embedded Linux without Android.
Okay. So I thought I saw some init messages coming up. Yeah, okay. System D. That's definitely not Android.
Yeah.
That's cool though.
Yeah. Now you are at the login prompt. So other things are starting, but that's more or less what I want to show with the GDB. Some Docker stuff is also coming up. As you can see here, it's in Linux 5.15.
Mm-hmm.
Okay, so I will power down the device.
Okay.
And switch to the lldb setup. Takes a few seconds to shut down. Okay. Now it's down. I close my GDB debugger and Okay, now I'm booting again into the bootloader, into U-boot. Want to show the lldb session now.
Okay, cool.
Again, booting to the U-boot shell and starting the same GDB server. And now I'm using this tmaxinator Voltron setup to start the lldb debugger. It uses a local lldb init script. All those software which I customized, I can share. Takes a few seconds to connect to the GDB server. Now he did it. And he will fill all those windows with initial information after reading from the target. So now you see here that we are in the very first instructions, or normally the other parts of the Windows also refresh.
Mm-hmm.
Takes a little bit long now, but okay. Anyway, I go into the command section here and try to start the target. I think it starts, and now it waits for the Linux kernel. Okay, triggers the breakpoint. Now it asks for information. You see the source of those. Normally the other windows are also refreshing. I'm a little bit puzzled why they are not doing at the moment.
It's the demo effect.
Yeah, that's demo. It's really the first time the other windows are not refreshing. Don't know. So I continue. The next breakpoint should trigger. Okay, now the other windows are also refreshed. That's a really nice setup in order to get all the information you need in parallel. And yeah, I can totally boot through like I did with the GDB setup. Yeah, that's what I want to share with you guys.
And you mentioned that you have to have a plugin for GDB that the source code is showing and how is it spelled? You mean Jeff?
It's spelled Jeff, G-E-F. I can show them maybe the website for that.
Jeff, okay.
Jeff, yeah. That's not.
Okay, so
it's more or less in this box here.
Yes. GEF, yeah.
GEF, yeah. That's the extension for the GDB, and I used for the lldb another thing which is called Voltron.
Okay.
Chris has my slides, and yeah, you can feel free to give it to the community. And I can also give the patched Voltron, because it will not work right out of the box for AH64 at the moment, and did some slight modifications in order to get it running.
Okay, thanks.
I can make a package and send it to Chris, and maybe he can also provide this information.
Yes, please do that. I will post that along with the slides and the videos. Yeah, as part of the wrap up for this, which I'll do tomorrow morning.
Yeah, thanks, guys. That's what I want to show.
So that's very cool. So anybody have any questions on that, or similar experiences of doing board bring up and debugging using JTAGs and open OCDs and such like?
Do you have to configure something in U-boot before you start the kernel?
You have to configure a TFTP server and an NFS server. That's quite usual. You have
it on the host system. You can configure it on the host system, or TFTP and so on.
Yeah, on the host system, exactly. What's very important is to use the no cancellare option, because address randomization will prevent doing debugging. So that's very important to use these no cancellare option when you start the kernel. That means the command line for booting the Linux kernel from U-boot has to include no cancellare. That's very important.
You don't need to compile it with this flag. You only have a
no. It's just a command line thing. It's a command line thing. Yeah, you have to provide to the kernel command line no cancellare.
For switching off address randomization.
Exactly. Only then the breakpoints, especially the breakpoints, the very early breakpoints trigger.
Okay.
And I'm guessing the fact that you're using TFTP and NFS for the kernel image and the file system, I mean, it could be from anywhere. It could be from flash memory or wherever.
Yeah, sure. It's easier to develop in that kind of environment. That's
Indeed,
the only reason.
That's the traditional embedded way of doing things.
Yeah.
I would like to ask, how would you switch between different processes? So if you now break in the debugger, how do you switch from one process to another or from one context to another?
I really did that only to debug Linux custom kernel modules. And I did not show the full story. When you trying to debug kernel modules, custom kernel modules, you have to provide additional symbols. And the debugging I had problems from starting some kernel modules. So I had my goal was to debug from the very early phase when he probes for a new module. And there's a methodology where you can stop at a kernel place where generic Linux kernel modules will be called, and just before you can assure that with a question that your kernel module will be loaded in the next step, and if it's the case, you can then dynamically reload the symbols for your own provided custom kernel module, and then you're able to debug kernel modules from the beginning. That was my motivation to do such things. So I'm not switching through processes. I wanted to debug a Linux custom kernel module from the beginning.
Okay. Yeah, sounds really cool about reloading those symbols for kernel drivers, because that's indeed often an issue with not being able to do that especially on an embedded device.
If you'd like, you can contact me and give you the recipe exactly for doing this, because this is something I did not show now. It takes a little time to do that.
Thank you. Yeah, definitely. I would like to
just send me an email.
Give it a try.
Yeah.
Okay. Thanks.
So I certainly remember doing something somewhat similar on a Raspberry Pi, trying to debug the Android initialization some while back when it wasn't working. And I certainly learned a lot about the early Android init process, which up to that point, I wasn't fully sure how it actually worked. We could actually step through and see how it parsed the file descriptors and worked out what was what. Admittedly, that was not doing kernel debugging, that was doing user space debugging. I was just debugging PID1 as the init program came up. But it's a great way of learning how the whole system fits together. Yes, highly recommend it.
Yeah, thank you, guys.
Okay, thank you very much, Jürgen. Okay, well, we're coming towards the end now. So let me begin by just opening out to the group. Does anybody have anything, any questions that they've been sitting on for the last hour and such that they'd like to ask the people who are here? Or any other things they would like to mention, interesting projects or interesting events that are happening?
I have still a question to the last GGBDB session. Is there a way to connect the Raspberry Pi with JTAG? Is this on the normal I/O? On the normal contact?
I can, if it's possible, I share my screen again, and
Sure.
you have to add something into the config.txt file in order to enable JTAG from the beginning. That's what you're asking for.
But where are the contacts?
The contacts are on the Raspberry Pi header. You need 6 wires, and on the Raspberry Pi header, you have to check the schematic scheme. It's available on the internet, and there is JTAG on 6 wires. But you have to add something to config.txt. I'm trying to show you. Hopefully, I find it directly. It's this here. Maybe I make it a little bit bigger.
And which JTAG device do you use?
J-Link. I use J-Link.
J-Link, okay.
From Sega. No, it's a very, very traditional JTAG device. It's
over
not
USB
so cheap. Yeah, it's over USB. USB to JTAG or SVD.
That's cool.
Yeah, this is the thing you have to add in the config.txt in order.
Yes.
And also, I think you need to set some pull downs. And these are the pins here, 22 to up to 27.
Okay.
You have to connect to the.
Did you find that more reliable than using KGDB, which would be the cheapest way of doing it?
Yeah, it's not so. Yeah, I done experiments with KGDB, and in fact, it worked for the x86 things, but for AH64 it was a bit too complicated for me.
And how is the GDB, the JTAG USB spelled?
I show you on the web. J-link.
Okay.
It's from Sega.
Okay.
This is a product here.
Yeah, it's been a standard component for embedded debugging for decades.
Yeah.
Yeah, 10 plus years, it says. Gotta be right.
Yeah. Okay, thanks.